All right, here's your homework preparing you for your quiz over targets 1 through 7. So just running through these targets, starting with target 1. So here we are deciding if we have a polynomial. So we're going to play a little bit of process elimination here. So first of all, in order to have a polynomial, all exponents have to be positive whole numbers. So they have to be positive, so B does not work. They have to be whole numbers, so E does not work. Beyond that, other things we have to look out for is if you have x in the denominator of any of your equations, which we don't, or if x is under any radical, which it is on A, so we got to get rid of A. The only other thing that we need to look out for is if x is inside absolute value brackets, but I don't see any absolute value brackets, so C, D, and F are all examples of polynomials. Taking a look at some graphs, still deciding if we have polynomials or not. So the things that we're looking for are smooth continuous curves. So when we talk about smooth, that means they don't come into any sharp points. So on D, absolute value comes to a sharp point, and F, this funky looking one, also comes to a sharp point. When we talk about continuous, that means that you can graph the entire function without picking up your pencil. That would not be possible on C, so we're also going to eliminate that. So A, B, and E are all examples of polynomials. A and E should make a lot of sense because we have talked about how quadratics and linear functions are both examples of polynomials, so we can spot those hopefully after first semester. Moving on to target 2. We are working through some operations with polynomials, so starting off with subtraction. So remember, not a bad idea anytime you have subtraction to rewrite your polynomial and distribute that negative, just to make sure you don't make any mistakes with that negative, with that subtraction. And then from there you combine like terms. So I only see one term that has x to the 5th, so I'm going to start there. Oh, I don't know why I said 5x to the 5th. 14x to the 5th. And then looking for the next biggest exponent just to organize my work. We have 5x squared. And then we have a couple terms that have an x, so that's negative 11 plus 8, which would be negative 3x. And then our values without any x's, so negative 6 plus 13, which would be positive 7. And I can't combine that any further, so that's my final answer. Very similar here on D. The only difference is that it's all addition, so I'm not going to rewrite. But I do have to be really careful with how I'm going to combine these like terms. So I'm going to start with x to the 4th y squared. And I think that's the only one that has x to the 4th and y squared. So 8x to the 4th y squared. Moving on, I'm going to do x to the 3rd y squared. X to the 3rd y squared. Here's x to the 3rd y squared. And one more. Okay, so I have 2 minus 13, which is negative 11, plus 12, which is 1. So just 1x to the 3rd y squared. And then all of the terms I have left are all x, y to the 3rd. So combining those, I have negative 11 minus 2, which is negative 13, plus 14, which would be 1x, y to the 3rd. And then we get into some multiplication. So remember, if you have 2 times 2 like we have on 3, you can use FOIL to help you. So if you do first, multiply the first terms, that would be positive 48a squared. And remember, FOIL is just a tool that you can use to organize your work. You don't have to think about it this way. O stands for outer, so that would be negative 32a when I multiply them. I stands for inner, so that would be negative 42a when I multiply them. And L stands for last, so that would be positive 28. Now you do have to simplify a little bit further because your two terms in the middle are like. So if I combine those, I get negative 74a and then plus 28. So FOIL only works when it's 2 times 2. So when I move over here to number 4, I can no longer use FOIL. I'm going to think about this as a double distribution. And so like I did on the homework, I'm going to actually write this out. So the first thing I'm going to do is multiply negative 3b by everything in the second set of parentheses. And you don't have to rewrite it like this. It is a good tool to organize your work. Not a bad idea to do this on the quiz, just to make sure you have all the distribution done. So now I'm going to multiply negative 8 by everything in the second set of parentheses. Okay, so now I'm going to actually do the distribution. And this might be where you actually start, and that's fine as well. So that would be negative 6b to the third minus 12b squared plus 21b. And then the second set of distribution is negative 16b squared minus 32b plus 56. And so the reason I stacked this up the way I did is that it allows me to combine my like terms when I have a lot of them. So I can just add down now. So I have negative 6b to the third. And then when I add down here, I get negative 28b squared. And then 21 minus 32 would be 11, negative 11b plus 56. And so on number 5, it's just one step further. So now it's 3 times 3. So I'm going to do the same thing. I'm just going to start with, or I'm going to start the same way. I'm just going to end up having 3 sets of distribution. So starting by distributing the 5x squared to everything. So 5x squared times everything in the second set of parentheses. And then 7x. Notice I'm keeping that sign, so it's a positive 7x. And then here's the third distribution, so a negative 8 times everything. Okay, so now I'm going to actually do the distribution. I'm going to stack it up like I did the last time. So starting with the red part, that would be negative 40x to the fourth. And then I would have 25x to the third plus 5x squared. Then moving on to the blue, I'm going to stack my answer under my previous one. So starting with negative 56x to the third plus 35x squared plus 7x. And now the final distribution. So that would be 64b squared. And then that would be negative 40x minus 8. And then I'm going to tally that all up here at the bottom. So my final answer would be negative 40x to the fourth. And then that would be negative 31, yeah, negative 31x to the third. And then this would be, that would be 104, I believe. X squared, negative 33x, minus 8. Okay, moving into target 3. So just talking about some characteristics of a polynomial. So talking about the degree, which is the number that's the highest exponent, the type, which is either going to be linear, quadratic, cubic, or quartic, and then whether the leading coefficient is positive or negative. So the degree here, the squiggle shape, is a degree 3. That's a cubic. Remember, degree 1 is linear, degree 2 is quadratic, degree 3 is cubic, degree 4 is quartic. You should know what a linear and a quadratic function look like. We're looking at an example of a cubic, and then a quartic is a W shape. If you notice this cubic is going uphill, that's because the leading coefficient is positive. From an equation, The first thing we want to do is make sure that it is in standard form, which means you start with the biggest exponent. So I'm going to rewrite so that x to the fourth is first. And then that's just going to help you out. So the degree, the biggest exponent, and now the first exponent is 4, which like I just mentioned is a quartic. And the leading coefficient we can now see is positive. Notice you do have to put that in standard form in order to clearly see whether your leading coefficient is positive or negative. Moving on to target 4, so end behavior. So whenever you're going to do end behavior, you start with the same notation. So you do x arrow infinity, f of x arrow, and then you're going to fill in the blank. Now on the quiz, guys, this will be given to you. So you will have, the quiz will look literally like this, and you fill in the blank. And so what I'm going to do, just for the sake of time, I'm going to take maybe, oops, I was going to take this, what I just wrote, I don't know that I can't, oh there we go, and I am going to just put it under each one. So notation you use every time, so it will be given to you on the quiz, but make sure that it's on your reference sheet. You might want to go ahead and just put it on your reference sheet so you have it when the test comes around so you don't forget. Now, talking about this notation, when you have x arrow infinity, if you think about the x-axis, that's the right side. And then x arrow negative infinity means the left side. And so what you're telling us is the end pointing up or down on the left and on the right. So what I like to do is use a graph. I sketch a little graph to help me with this. So this degree is 3, which is a cubic. And so we already talked about how the cubic has a squiggle shape. It also has a leading coefficient. So this is going to be a squiggle upwards. So on the right side, here's the right side, it's pointing up, so I say positive infinity. On the left side, it's pointing down, so I say negative infinity. So moving on to the next one, this is a degree 4, which is the W shape, with a negative leading coefficient. So it's a W, but it's opening downwards, so it looks something like this. Just a rough sketch, doesn't matter if that's what it actually looks like, it's just a sketch of it. So on the right side, the arrow is pointing down, so we say negative infinity. On the left side, the end is pointing down, so we say negative infinity. Both ends are going down. Now we have a quadratic, which we should feel a little bit more comfortable with. It has a positive leading coefficient, so it's a U shape opening up. On the right side, it's pointing up, positive infinity. On the left side, it's pointing up, positive infinity. So going to positive infinity, both sides. And now we have a cubic again with a negative leading coefficient. So this is going to be a squiggle, but it's going to be a downward squiggle. So on the right side, the end is pointing down, negative infinity. On the left side, the end is pointing up, positive infinity. And that is your end behavior if you're given an equation. If you're given a graph, it's much easier because you don't even have to sketch anything. Just look to the right and left. Okay, so now domain and range. So this first graph is a quadratic, so that should feel pretty comfortable. Your domain, how far to the left and right. Quadratic has a domain of all real numbers. The range is everything above this point. So remember, range goes with y. So the y value of that point is 7, and it's everything above 7. So we would say y is greater than or equal to 7. Then on 13, we have a cubic. It's a squiggle shape. So it's going to go forever to the left and right, but a squiggle also goes forever up and down. So both of them are all real numbers. And now we get some factoring, everyone's favorite. So when you're taking your quiz, since you don't have a reference sheet, really allow these last two targets, allow the directions to help you, because it truly tells you what to do. It says factor by grouping. So if we're going to factor by grouping, let's group the first two terms, group the last two terms. So this should look like first semester factoring to you. It's pretty much what it is. So in the first set of parentheses, there's a common factor of x squared. So I'm going to take that out, which would leave me with x minus 3. In the second set of parentheses, there's a common factor of 4. If I divide both of those terms by 4, I'm left with x minus 3. These two are the same. That means I did this correctly. So my factored form, I'm going to use one of the parentheses that's the same, and then your two common factors, x squared plus 4. Now remember, on these two targets, both of the factoring, you're on the lookout for the difference of squares. X squared plus 4 is not the difference of squares because there's a plus, not a minus in between them. So if that was x squared minus 4, I would continue factoring, and I'm sure I'll run into that case somewhere here. Okay, so then to find the zeros, we set each of the factors equal to 0. And then I'm going to solve. So if I add 3, I get x equals 3. And then over here, if I subtract 4, I get x squared equals negative 4. And then I have to take the square root, which would be x equals plus or minus 2i. Now, if you forgot the plus or minus, because that's a common mistake, remember that this was a degree 3 polynomial. The biggest exponent was 3. So you should have 3 zeros. So I have 1, 2, 3. So you can always double check that and catch that plus and minus if that's the case. All right, different numbers, same idea here on number 15. So factoring by grouping, so grouping the first two terms and the last two terms. So in the first two terms, the common factor is x squared, which would leave me with x plus 1. In the second set of parentheses, the common factor is negative 4, leaving me with x plus 1. So the two factors are x plus 1 and x squared minus 4. The reason I did not write this on the factored form is because x squared minus 4 is the difference of squares, so it continues to factor. So the square root of x squared is x. The square root of 4 is 2. You add 1, subtract 1. So the final factored form here would be that x plus 1, don't lose that, and then x plus 2, x minus 2. And now I'm going to set these equal to 0 and solve. So x plus 1 equals 0, x plus 2 equals 0, and x minus 2 equals 0. So subtract 1, I get x equals negative 1. Subtract 2, I get x equals negative 2. And add 2. I get x equals positive 2. So I ended with 3 zeros, which is good because this was a degree 3 polynomial. Moving on to the last target that's on your quiz. So it says factor and solve a quartic in quadratic form. So again, use the directions to help you. So it says in quadratic form because we're actually going to factor this just like we did a quadratic. So it's not a quadratic. We're just going to treat it like it was. So we're going to find numbers that multiply to 56. Remember a times c. And add to your middle number, which is negative 15. So the numbers that do that are negative 7 and negative 8. And because this starts with a 1, we can actually use the shortcut, which means we go straight to factored form. So normally we would do x minus 7 and x minus 8, but because this is a quartic, don't forget that you have to have squared and squared. So that's your factored form. You can go straight to it once you find your two numbers. Then looking at the zeros, so we have x squared minus 7 equals 0 and x squared minus 8 equals 0. So if I add 7 over, I get x squared equals 7, and that doesn't simplify. So when I take the square root of it, I get x equals plus or minus square root of 7. Over here, if I add 8, then I get x squared equals 8, square root, and 8 actually simplifies. So I'm going to say plus or minus 2 square root 2, which is the simplified version. And if you're wondering how to do that, so that's when you make your factor tree. And I had a pair of 2s, so a 2 went on the outside, and 1 2 left under, so 1 2 stayed under. And just like I talked about on the first target, or on the target 6, this was a degree 4 polynomial. 1 2 3 4. I have 4 zeros, so you can always kind of do a checklist at the end, make sure you have everything you need. All right, our last problem. So again, this is a quartic. We're going to factor it like a quadratic. So find numbers that give you a times c, which is negative 28, and add to give you your middle number, which is 3. So the numbers that multiply to negative 28 and add to 3 would be 7 and negative 4. And then if you think about this in factored form, and there's a reason I'm writing it up here. Remember, we can take the shortcut, so we're just going to factored form. Don't forget your x squared, though, because this is a quartic. And notice we have the difference of squares. Again, we had this one on the problem right above it. So the square root of x squared is x. The square root of 4 is 2. We add them, and we subtract them. Okay. So our factored form, x squared plus 7. Don't forget that one. And then our difference of squares, x plus 2, x minus 2. And then we're going to write the zeros, so set them all equal to 0 and solve. All right, so I'm going to subtract 7 squared. And then take the square root. So now I have a negative under square root. So that would be plus or minus I square root 7, since I had a negative under the square root. And then I have x plus 2 equals 0, x minus 2 equals 0. So I get x equals negative 2. And here if I add 2, I get x equals 2. And again, just kind of doing that checklist, 1, 2, 3, 4 for degree 4. So that's all the stuff that's on your quiz. Good luck. You will be awesome.